Hey guys, how's it going? Welcome to another video. I know what you may be thinking, finally, but stuff has been happening in my life, so I didn't have as much time to prepare this video, but I do want to, take my time, so I'm going to apologize in advance if this video is going to be long, because we're going to cover something actually quite important today. And we're going to be starting off with the first portion of our actual concrete RGSS programming experience. And today we're going to be going over sprites, how to use them, how they work, what they represent, the different functions they have, and basically everything to do with sprites. But before we can go any further, there's one important thing we have to understand the fundamentals of before we can actually continue, and it's to do with the coordinate system in RMXP. So the coordinate system in RMXP, like the coordinate system in every 2D plane, is going to have a x-axis and a y-axis. But the important thing to note here is that the coordinate system starts at the top left corner of your game window. So unlike traditional coordinate systems where you have an axis and the y and the x-axis intercept at the bottom left corner, this is going to be the exact reverse. So as we go down the screen, we're going to be increasing our y coordinate, and as we go right to the screen, we're going to be increasing our x coordinate. Now there's also a third plane of depth, so to say, because RMXP is a 2D engine, so it's very limited to the 2D plane, as you can probably tell. You can't really do any 3D stuff, but there is a way to order elements on screen. So if you want something to appear on top of something else, you can do that. And intuitively, this is the Z coordinate, but it's more of a spoofed Z coordinate instead of actually a real one, which is going to go towards the user, let's say, and the higher value you have of the Z of your item, the closer it's going to be to the user, i.e. it's going to appear on top of all the other elements. So this is very important to note, because our sprites, as well as our viewports and bitmaps and everything else, is going to be relying on this coordinate system that starts in the top left corner and then progresses downwards and to the right. Now, if we talk in terms of pixel art, anything that we actually draw in pixels, we could consider a sprite. So the whole graphics file is going to be a sprite. And it is very important to separate this terminology from an actual sprite that's being used in RGSS. Because a sprite in RGSS, it represents a content wrapper, which is going to have a lot of different things, a lot of different parts comprising together this one system, which is then going to tell the RGSS player and the interpreter to render certain elements and certain pixels on screen as you want them to show up. So the sprite contains mainly of three main parts. So you have the viewport, which I'm going to talk about in a bit. You have the actual sprite itself, which is going to be the content wrapper, and then you have the sprite's bitmap. And the bitmap is going to be the object that is responsible for storing all the information about the different pixels inside of the sprites, which is basically going to act as an interpreter of your graphics file that you actually have in your projects folder. And it's going to be an intermediary between translating this graphics file into actual displayable pixels on screen. So to start us off nice and slowly, we're going to be talking about viewports first. And viewports are very simple to grasp. They're basically rectangles which represent a designated area of your game window, which you're going to be able to render certain elements in. So each sprite is going to be given a viewport at its initialization stage, and then this viewport is then going to denote the bounds within this sprite can actually be rendered on screen. And viewports get initialized by starting the term viewport.new, and then inside you pass 4 parameters. So the first one is going to be its x coordinate, so the x coordinate where it actually starts in your game window. The second one is going to be the y coordinate, and then the third parameter is going to be the width of the rectangle. And the fourth parameter is going to be the height of the rectangle. So basically with these 4 parameters, you're defining the endpoints of the rectangle, and inside of those endpoints and inside of this rectangle is where your sprites are going to be rendered at. Given circumstances where you have multiple viewports, and like we've talked about previously in the coordinate system, you can also assign a Z value to your viewport, which means that you're going to be stacking this rectangle which within certain sprites are going to be rendered on top of other viewports and other rectangles for displaying graphics inside of them. And this can be quite useful if you want to have a scene appear on top of another scene, or if you just want to cut out certain rectangles and have like a portion of information be displayed there, as opposed to having to manipulate and count for those chunks of sprites elsewhere. And it's very useful in cases where you want to isolate sprites onto separate viewports so you can manipulate them accordingly. Now, another aspect of viewport, which is a different part of this discussion we have to go in, is that viewports can also be given tones or colors. Now, there is a big difference between tones and colors in RGSS. A tone would represent a tint each and every one of your rendered pixels is going to obtain, while a color is going to represent the color of the pixel that's going to overlay each of the pixels that you're rendering inside of the viewport. So it's very important to note these two differences, and they also get defined a bit differently. So tone is a tone.new object, and it accepts the RGB parameters, so red, green, blue values for the colors, but it also has a grayscale, which means that you can basically make all the sprites inside of your viewport fade into a tone of gray or something like that. So their saturation when it comes to the color is going to be either turned up low or turned up high. And colors are of color type new class, which are going to accept the same RGB, so red, green, blue parameters for the pixel color, but then they're also going to have an alpha value instead of a gray value. And this alpha value is going to determine the opacity of the pixel, so the pixel of color that's going to be displayed on top of all of your rendered items inside of your viewport. So in case you want to have a scenario where you want the screen to flash, you would use the color to overlay your viewport in a white color, but have its alpha value be 0, and then the alpha value would fade into full opacity and then fade back out for the flash. While if we did with the toning, you could achieve the same effect by basically increasing the tone from 0 to 255 on each and every one of the pixel colors. But the tone, like I said before, behaves a little bit differently from colors, because colors are going to be overlaying their color of pixel on top of your rendered sprites, while the tone is going to take the actual pixels of the sprite or the bitmap or whatever you're applying the tone to, and it's going to change the tint of each of the individual pixels inside of that given sprite or the viewport. So now that we've quickly glossed over viewports and what colors and tones are and the coordinate system in RMXP, why not get onto sprites? So sprites get declared by, like everything else does with a new class, everything is an object in Ruby, which is true for sprites as well. So we start off by assigning a variable name, we write the name of our variable, we write equals, then we write sprite.new, and inside of parentheses we have to give it an argument. Now the argument it accepts is going to be the viewport argument. Now this parameter is actually optional, so you can give it a viewport in case you want to assign the sprite to a certain viewport that you've defined before, which should be the common practice for you to use, or if you omit the viewport value, it's going to create a sort of temporary viewport for just this instance of this sprite in particular. Now this is good and bad depending on how you look at it, because it lacks the control you have when it comes to regular viewports, so you can't, directly alter the Z value, and you can't stack the viewports on top of others. So depending on how you render your sprites, if you forget to put in the viewport, you may not actually see the sprite appear on screen. So very good and very common practice that you should get used to from the beginning is actually defining a viewport alongside your sprites and then assigning that viewport to your sprites, so you have a better control over the sprites you want to actually display on screen. But now that we've defined our sprite object, this doesn't really do much for us, because now we have a sprite. And like I mentioned before, the sprite is not actually a graphical file of sorts. It's more of a way to interact with the renderer and tell it what to draw where. So now that we have our sprite, we have to give it the information that it needs in order to be able to draw pixels on your screen. And this is what's called a bitmap. And depending on your use case, you may or may not want to do different things with the bitmap. But again, like with everything else in Ruby, like with all the other objects and classes, you initialize a bitmap, but you assign the bitmap to the sprite by doing sprite.bitmap equals bitmap.new, and now we open parentheses in order to pass it a few arguments. Now what you can do is you can give it a string, which is going to be the path name of your file that you want the bitmap to load. So if we pass in as a parameter a string which says graphics/pictures/test.png, this bitmap is now going to take the graphical file, it's going to read each and every pixel inside of the file, and it's going to store that information and relay that information onto the sprite, and the sprite is then going to render all those pixels on screen accordingly. Now what you can also do is you can create a blank bitmap, and this is basically going to create a rectangle which doesn't have any pixels filled in. And this could be useful if you're wanting to draw certain shapes or certain things through your code like text onto a bitmap. And the way you do this is the same thing. You do sprite.bitmap is equal to bitmap.new, and inside of the parentheses you give it a width and a height parameter, which is pretty much just going to determine the size of the rectangle of your bitmap. And at this point we don't really care about much else, since the interpreter is going to, and the RGSS player, they're going to do their job with communicating with the different objects and rendering your pixels on screen. So depending on what your actual bitmap is, that is what you're going to see on the screen. The bitmap doesn't have its own X and Y positions, its own X and Y coordinates, because that's going to be pretty much handled by the sprite content wrapper. Now, a third part of the sprite is the src_rect, which you may or may not have seen before, but I'm pretty much going to give you a rundown of what it actually is. Now, this rectangle is actually very much linked to the bitmap. So this rectangle is going to define the, let's say, viewport of the bitmap you're going to be actually seeing inside of your sprites. So I know it kind of gets Inception-ish when you think about it. You know, you have viewports. Inside of those viewports you have sprites. These sprites have their own bitmaps, and they have their viewports for their own bitmaps. What? It kind of gets complicated, but it's actually very simple. So the src_rect is going to be a rectangle which is going to then cut the bitmap file you have given your sprite and display only a certain chunk of it as the sprite. Now, by default, whenever you assign a new bitmap to your sprite, this src_rect is going to be positioned at 0, 0 on the bitmap file, and is going to have the width and the height be equal to the bitmap file. So this basically means that you're going to see the entire bitmap as a sprite on your screen. But what you can do is you can use sprite.src_rect.set, and inside here we can pass it 4 parameters, just like with the viewport. So you can pass it an X coordinate, a Y coordinate, a width, and a height value. And this is pretty much going to take your bitmap file, and it's going to slice out a little rectangle from your bitmap file and then use that as its sprite, which is then going to display on your screen inside of the viewport. So this can be very useful in case you have sprite sheets and you want to cut them up into different slices and then just manipulate the X and Y position of the slice in order to be able to use different parts of the bitmap file. Or this can be useful if you have, let's say, a scrolling panorama image, which is then going to, you know, continuously scroll through a certain image file, giving it that, you know, illusion that it's constantly going in the background. So it's very useful for many different things, and it's actually used in a lot of parts of stock RMXP. I'm not even talking about Pokemon Essentials here. You can see it in the sprite sheets for, of course, the character sprites, in the tile sets, in the animation editor for the sprite sheets of the animation graphics itself. So it's very commonly used, it's very important, and it's a very useful little tool, you know, to keep at the back of your head, just in case you need something like that. Phew, that was a lot of information to process, but we're actually, unfortunately for you, not done yet. So now we've talked about viewports, we've talked about bitmaps, we've talked about the coordinate system, we've talked about colors, we've talked about tones, and we've talked about src_rects. But now we have to talk about the actual sprite and what the content wrapper itself has as functionality. So of course, the sprite is going to have its X and Y coordinates, and going back to the coordinate system, that's going to, you know, determine the position of the sprite inside of that particular coordinate system. So the X and Y values are going to be there for you to adjust your sprite horizontally or vertically, depending on where you want it to appear on screen. And it's also going to have its own Z value. Now the Z value, just like the viewports, is going to determine the order in which to stack the sprites on top of each other inside of that viewport. So again, it's very Inceptionist, because you can stack viewports on viewports, but inside of those viewports you can also stack sprites on top of sprites. So there's a lot of stacking going on, and there's a lot of similar functionality between all of these different aspects, which then, you know, come together and combine themselves to make this one full coherent system. And apart from just simple X and Y coordinates, we can actually also change the coordinate of origin of the sprite itself. Now, this is a very weird concept at first, but it makes a lot of sense. So the sprite itself, the container, is going to be handled from the top left corner of the sprite, because that's the natural way of doing it in this coordinate system that RMXP uses. But what we can do is we can shift this point of origin from which the sprite gets handled, and we can move it about the entire position of the sprite and even go beyond the rectangle that's defined by its bitmap. So you do this by using sprite.ox and sprite.oy values respectively. So what you can do is, if you align the ox value to be at the center of the width of the sprite, and if you align the oy value to be at the center of the height of the sprite, you're pretty much going to be moving your sprite about in the coordinate system, but the point of origin is going to be the very center of the sprite. So this is going to be where you're going to be grabbing the sprite from, to say, you know, in very simple terms. And then with this point, you're going to move it around your coordinate system. And it's kind of weird for me talking into the mic like this right now, because I don't have the visuals with me, but you're going to be seeing it on screen, and hopefully that's going to make it easier for you to understand. But you have the X and Y coordinates, you have the Z value, which is going to stack the sprites on top of each other, and then you have the OX and OY value, which is going to determine the center point of your sprite, which by default is the top left corner. And why this is important is for other functions and other sprite transformations, like the angle. So you can give it a sprite.angle, and then you can increase the angle or you can change the angle, and this is basically going to make the sprite pivot around its coordinate of origin. So if the OX and OY value are left alone, you're going to take the sprite from the top left corner of the actual sprite, and then you're going to pivot it around that. And now, depending on the stuff you may or may not want to do, this may or may not be the behavior you want. In case you want to actually rotate the sprite around its center, you're going to have to align the OX and OY values to be at the center of the sprite. And then when you give it a value of angle, you're going to be rotating it basically around that axis. Another function which uses this center point of origin for the sprite is the zoom_x and the zoom_y functions of the sprite. And these, just like the name which suggests, are going to stretch your sprite in a certain direction. So the zoom_x value is going to stretch your sprite in the horizontal axis, while the zoom_y is going to stretch your sprite in the vertical. And if you stretch your sprite by a proportional amount of zoom x and zoom y values, you're pretty much just going to zoom in and out of your sprite normally. So this also gets determined, and it gets calculated based on the OX and OY values of the sprite. So in case you want the sprite to zoom from the center, you have to align your OX and OY values to be at the center of your sprite. And these two, the zoom x, zoom y, and angles, are pretty much going to be the only one that are very heavily dependent on this positioning of the center coordinate of your sprite. And like with viewports, sprites also have a tone and a color function, which is pretty much going to do the same thing it does with the sprite as it does with the viewport, but it's only going to be scaled down onto the sprite itself, not the entire viewport. So depending on what you may or may not want to have for your functionality, you may or may not want to use this feature, for example, for turning a sprite from its normal color to a blue color when you mouse over it, or something like that. And the final few points I want to talk about include the mirror function of the sprite, which, if you do sprite.mirror equals true, is going to flip the sprite on its vertical axis, which pretty much means you're going to mirror it in the horizontal direction. This mirroring only works around the vertical axis and it doesn't work around the horizontal axis. So in case you want to flip it vertically, you would have to first mirror it horizontally and then flip it by 180 degrees using its angle transformation. But an important part of knowing when to make sprites is also knowing when to get rid of them. And this function is actually also applicable to viewports as well. So in order to optimize your system, in order to optimize your game, you don't want the sprite to be on screen indefinitely long. So after you're done using the sprite, you want to actually be able to get rid of it, because that's just going to take up resources in the form of your processing power and your RAM. And this is actually no bueno when it comes to coding and things like that. So what you can use for both viewports and sprites is you can use the .dispose function, which is then going to get rid of the sprite. It's going to delete the sprite or delete the viewport, and it's going to get rid of it from its current cached state. And you can check if a sprite or a viewport is disposed by using the .disposed function. But this pretty much should be, again, very common practice for you. So every time you actually draw sprites on screen, when you're done using those sprites, you should always dispose them, as to, you know, not have them either hanging on screen for a moment before the garbage collector actually comes around and disposes them automatically, and to further, you know, optimize your game to make it run as smoothly as possible. And as I'm ending the video, I do want to give you like tips and tricks, if you can call it that. But the way, for example, Essentials utilizes sprites and the way it groups sprites together is by assigning a hash name for the sprites. In most common scenarios, it's @sprites equals and then the two curly brackets denoting the hash. And inside, the way you define sprites is you would use @sprites open square brackets. Inside, you will write the string denoting the sprite, and then equals sprite.new, and you continue with your magic from there. And what this allows you is to simply iterate through all the sprites, because let's say we have 20 sprites on screen, and let's say we want to dispose all those 20 sprites at the end of our scene. Now we of course could give each and every sprite a individual, you know, unique variable name. And then when it comes time to disposing the sprites, we go through each and every one of those sprites manually, and then we dispose each and every one of those sprites manually. But what you can do is you can write a simple loop, which is going to iterate through the sprite hash using the keys of the sprites, which we talked about in a previous video, which I'm going to have annotated on the screen, so you should check it out if you haven't already. But what you can do is you can have a loop which is going to iterate through all your sprites inside of your hash, and then it's going to automatically dispose of them. And this is very nice. This should also be common practice. You should group your sprites depending on what you want them to represent in your system. For example, you may want to separate your visual UI elements from your functional UI elements and sprites and stuff like that. But you should always I mean, you don't have to, but it's very good practice to always, you know, have a certain hash which is then going to handle all of your sprites together for when it comes time to apply mass transformation onto all of your sprites. Because if you get to the point where you have 100 or 200 different sprites, it gets very tedious very quickly, you know, having to go through each and every one of them manually. So you can write loops to, you know, bulk move your sprites around, to bulk change their opacity, to bulk change their color, bulk change their tone, their opacity. Did I say that twice? I think I did. And visibility and things like that. So it's a very useful tip to keep in mind, I think, because in the long run, it's going to make your life a hell of a lot easier than it potentially could be. But I'm going to wrap up the video here for now. From what I'm seeing in the recording section, it's been, what, 24 minutes right now? So I don't want to make these videos, you know, half an hour long and overly long. But that's going to be it for this video. Again, if you have any issues, as usual, you can leave them in the comment section. I'll try my best to read them if I get notified. If I don't, I'll still try my best to leave them. You can join our Discord. You can contact me there. And if you have any other questions, or if I was, you know, talking my way very quickly through all of this, let me know and I'll try to get back to you as soon as possible. But that's it for me for this video. This video has been a bit longer. It's a bit more complicated because we are now getting into the more serious stuff when it comes to RGSS specific functionality. So the next few videos are also going to be a bit more complicated than these videos have been so far, because so far we've only been at the introductory level, you know, doing the basic theory of programming and stuff like that. But hopefully you guys enjoyed this video. Hopefully it wasn't too long. Hopefully you took something from it of value. You understood the stuff I was talking about. And yeah, you guys take care, and I'll be seeing you in the next one. Bye-bye. If you like or dislike this kind of content, let me know down below by pressing the like or dislike button. Subscribe to the channel in case you want to stay up to date on all the videos I publish. You can follow me on social media for other updates and general news. And if you really want to get in touch with me, you should definitely join the Discord chat room, because that's the best place to be at. If you're wondering what else you can watch, some videos are going to be on screen, so enjoy.